Hi everyone, and welcome to the fourth video of the Peer Club R series. Today I will be giving you a short introduction into data manipulation in tidyverse. So first of all, what is tidyverse? Tidyverse is a set of really great packages, some of which I have already mentioned, like ggplot2 or for example dplyr and tidyr, which are also the packages that we are going to be using today. Then there are packages like forcats, which is helpful for working with factors, lubridate, which is useful when you're working with date and time, and for example, broom, which is a really great package if you want to run multiple linear models across different variables or across different groups, and you want to have a really nice and tidy output, then I would definitely recommend using broom. I am planning on having another video where I will be showing how to use broom and also how to use ggplot in combination with dplyr and tidyr. But today, I think it's just good to have a really short, nice introduction into the basic functions from dplyr and tidyr. Just quickly before we move to RStudio, I want to introduce Hadley Wickham, who is one of the main authors of the tidyverse. He has also published the really great book, which is R for Data Science. I have a printed version of it just because it's really awesome. But of course, it is nice to have something online, and he is providing this book online as well. So if you just follow this link, you will find the book. And there are also many of the functions that we're going to be using today with a lot of examples and explanations. So something that I can definitely recommend. Also, I'm just going to mention this quickly again, that there are cheat sheets that you can download either from this link that I'm providing here or directly in RStudio. And for example, there are cheat sheets for ggplot2, also for dplyr and for per and forcats. So just so that you don't forget that you can also download these, work with those, because they're providing some small visualization of how these functions work, which I think is really nice to have. Good. I think this is already everything that I wanted to show as an introduction. I will not be providing these slides just because there is not much on them, but I will insert these two links into the comments below the video. So I've now switched to the RStudio, and today I will be again working with a script that I already prepared. I will be posting this script in the post after I've posted the video on Facebook. If you find anything that you do not understand, you can always email me afterwards or just leave a comment below the video. We will not be using any specific data sets today, so I'm not providing any data. It's going to be a data set that we're going to be downloading basically and using from a package. So there is no necessity to change your working directory, and it doesn't matter if you're working in a project or not. You can just basically follow along and also add some of your comments wherever you think you need any, because this script for me at least seems very easy and very straightforward. So I haven't added almost any comments. Basically, I've just subdivided a few sections. So you might want to add a few of your own comments to this. So the first thing you will have to do is to install the tidyverse. If you haven't done so, you can either do it manually. So you can go to install and then just type in here tidyverse and then install it. Or you can also use the function install.packages. If something is going wrong and it's not working, then just try to maybe, for this case, install the packages dplyr and tidyr, because these are going to be the only ones that we're going to be using today. If this is not working for you, and for some reason you can't install some of the packages, at least try installing dplyr and tidyr, because these are the packages that we're going to be using today. And in general, try to install all other packages individually, or just contact me and let me know if you're having any troubles with that. So if we were able to install tidyverse, then we can now use library to basically load the package. And whenever you do that, you will see that you're going to get something like this output. Don't get scared if you get any warning messages here. That's totally normal and it's totally fine. The only important thing is, and this is something that I'm going to mention already now, and maybe you will not understand what I mean, but you might encounter that problem, is that if you're using plyr, so not dplyr, but just plyr without the D, and dplyr in the same session, then as far as I know, it's important to basically first load plyr and then load dplyr, because they have some similar functions that are going to be masked by the package that you load second, basically. And because we want to use dplyr mostly, it would be, of course, helpful if all the functions from dplyr are working properly. So just keep in mind, if you encounter any problems with dplyr and it's not doing what you want it to do, just check if you have plyr loaded and if you have loaded plyr before you loaded dplyr. And if, again, something still does not work, let me know. Today, we will be using the dataset palmerpenguins, which comes from a package of the same name. I think this package is developed by Alison Horst, so you can also find the package on her GitHub. By the way, Alison is doing some great illustrations of some of the basic functions, not only in dplyr and tidyr, but also generally in R. So I would definitely recommend to check out her GitHub. You can install this package either directly from cron, which is given in line 28, or you can install it directly from Alison's GitHub, which is given in line 29. Once you install the package, we can load the package using the function library. So this all looks fine. And then if you want to check which data sets are within this package, and this is something that I just honestly discovered, and this is really great, you can just use the function data. They already showed you, I think, at the very beginning of these videos, and then just provide the name of the package. And this will tell you that there are two data sets inside, penguins and penguins raw, and we are going to be using the penguins one. So to get this data set, again, you just type in data, then the name of the data set, and then you can look at the entire data set here. And we also see that in our environment, we have the new data set penguins. It has 344 observations and 8 variables, and these are just the first 10 rows. And we can also check the structure of the data set, which is telling us that there are species, island, and sex, which are factor. And then we have a few other numeric variables. We have the column year here, which is an integer, but we will be changing it to factor later on because it's going to be much more helpful having it as a factor rather than an integer here. Okay, so there are a few really, really basic functions in dplyr. They're all used to subset your data set depending on the relevance of the columns and the rows that you're interested in. So for example, the function select is used to select columns of interest. So for example, we know here that we have the columns species and island. So I just want to see what is given in these two columns. And then what you do is basically that you just use the name of your data set here, which is penguins. And then we use this pipe operator that I already introduced, which is basically combining these two functions and telling R it should start with penguins and do something with it. So we're starting with penguins data set and then using the function select. And in this function, you basically just give the names of the columns that you're interested in, okay? And if you just run this one line of code, it will here show you only these two columns. Note that I did not assign this into a new object. So basically our data set penguins, which is great, is still the same. So nothing changed here. It still looks the same and it still has all the columns as before. But the only thing that we see in the console is exactly the columns that we selected. You can, of course, also save this into an object and just give it another name or something. But today I'm going to try to just show you the output that you get if you use some of these functions. Okay. Another thing is that you can also, for example, select columns that all either start with something specific or end with something specific. And we know from here that we have two columns that have the word bill in them. Okay. So what you can do is that you, again, go here, you take your data set, then you use the pipe operator and the function select. And here we are saying to R that we want to have all columns that start with bill. And what we get are exactly these two columns, so the bill length and the bill depth. Okay. One thing that I might have explained before, but I'm just going to explain it again, is that what also works is basically putting this name of the data set directly in the select function without having to use the pipe operator. I will just demonstrate this quickly in the console. So what you can also do is just select and then penguins. And then basically the same as we had before. So for example, species and island. And R will know that penguins is exactly the data that you're interested in, and that these are the columns here that you're interested in. So if you just run that, it will basically give you the same output as we had before. The reason I like doing it like this is that I always know which data set I'm working with without having to go into the specific function and see what's the first thing that is standing there. And also, if you're later on combining several functions, not only from dplyr, but also just from base R, that are all referring to the same data set, it is just much better to have the data set outside here. So it's the first thing that you write, and then you use the pipe operator, and then you use all the functions that you want to be working with. You will encounter cases where you also have to use something different. For example, we're just going to put this in here, and it's going to give the same output again. What you can do is, for example, use these functions as I just showed it, or if you have the data set outside of the function, but you still want R to know that you're referring to this data set, you can also add a dot here and then a comma. And this dot basically stands for the data set, okay? It can be the entire data set, or if you're applying several functions, it can just mean whatever is created until the very line where you use this specific function is basically then taken over and being replaced here with this dot. Okay, so if we do that, it's again going to give us the same output. Sorry, this is all confusing. The easiest way is really to do it like this. And that's what I will be keeping throughout the entire script. But just so you know, if you should be doing something a little bit more advanced with this, just keep in mind that you can also replace the data set by a dot, or that you can also use the name of the data set within the function if you want to avoid using the pipe operator. The next function is filter. This one is used to select rows of interest. So for example, we want to have all rows that refer only to the species Adelie. So what we do is just filter, and then we say species equals to Adelie. Keep in mind that you have to use the two equal signs if you're comparing something to each other rather than assigning something to each other. So we see here that this data set has these 10 rows and then 142 more rows. So it's not the 300 as we had before. And this is because we have subsetted our data set by just looking at the species Adelie. If you, for example, want to get rid of these NAs here that we have, so for example, in the column sex, we have a few NAs, which are really not helpful, then you can just insert this as well as a condition. So we're going to use filter again species Adelie, and then we're going to say end, and we're going to say is NA, which is checking if something is an NA value, so not available. But we not want to have these values. We want to have all the values that are not NA. So that's why we need the exclamation mark here, which is basically negating whatever we're looking for. Okay. So if we do that, you see that the output is a little bit different. So it's basically the same as before. It again starts with 39.1 here, so that's fine. But these NAs here that refer to the sex, so all the lines that had an NA in sex are now removed. Okay, good. And then, for example, if you want to just extract data that again refers to a condition, something like something is higher than something or lower than something or within something, then you can again use these operators here like larger than, smaller than, and then equal sign. So here I'm looking for all bill lengths that are either larger or equal to 40. And we can just include everything together within filter. And then here we're going to get all the data where the bill length is above 40 or equal to 40. Next function is slice. Slice can be used to select rows by their integer location, whatever this might mean. I will just show how it works. So for example, if you're interested in the minimal value of something, but you do not want to just have this value, which you could do with just min, and then you would put the condition inside, but you want to have the entire line of the data set that is giving you the entire information around this value, then you can here use slice min, for example. And here we want to have the row that has the smallest bill length. Okay, and this is just going to give us one single row. And we know now that the minimal bill length is given for the species Adelie from the island Dream, and it's a female from the year 2009. Okay, and you can do the same for a maximum value. So here again, we're going to get just one single line that is telling us that the maximum bill length comes from Gento, from Biscoe Island, from a male penguin from the year 2007. So this was just giving you one single row, but maybe you're interested in the mean values across groups. So what you can do now is to use the function group by, which also comes from the dplyr package. And here you can put all the columns that you want to group together. So we want to have groups that are subdivided by species, sex, and the year. And we haven't talked about this, but I'm just going to mention it that we have in total 3 species. So it's Adelie, Chinstrap, and Gento. And we have 3 years, 2007, 2008, and 2009. And then we have the females and the males. And then the next thing that you want to do, similar as before, is that here again, you want to have the minimum value for the bill length. And if you do this now, you will see that you get slightly larger output, because now you're going to get a minimum value for each species, each sex, and each year. You see here that it starts with Adelie and then with Chinstrap. And you see here that for sex and for the year, we have, for example, here 3 females, because each of these is representing 1 year. And then we have 3 males, also each of them from one of the years. We have an NA here because I have not removed the NA, so just ignore that. And then we're already going to the next species, which is Chinstrap here. And again, we have 3 females and so on. You can see here that there are 12 more rows that I'm not showing here. But basically, you can tell that this worked. So this time you have for each of the species, each of the sexes, and each year, a minimum value for the bill length. If you, for example, are just interested in the Chinstrap and you want to exclude any values where the sex is not determined, then you can first use the filter here. So this will just filter the species Chinstrap, and it will look for all values that are available for sex. So something where you know it's either female or male. And then again, you can just use group by. And here you do not have to specify the species anymore because you just filtered only one single species. So it's enough to just specify sex and year here. And then you can use, for example, slice max, and this will give us the maximum values for the bill length. And in this case, we do not want to have only one single row for each of these groups. So we want to see the 3 highest values for the bill length. Okay. And if we do that, then this is the output that we get. So we see here, we have Chinstrap. That's the only species that is shown here. And we can also see here that it only occurs on the island Dream, by the way. And then we see here that we have the females and then the year. And for each of these years here, we have 3 females. Okay. So year 2007, there are 3 females, 2008, 2009. And for the males, there is the same. So that's why we end up with 18 observations in total. And we see here, these are the highest values that we get. So for the females in 2007, we get 58, 47, 46.7, and so on. Then the next function to use is relocate, and this can be used to reorder columns. For example, let's say you want to relocate the column year, because in this case, it is at the very end of the data set, but you maybe want to have it at the very beginning. So if you just use the function relocate, and then you specify the name of the column, R will automatically assume that you want to place this column at the very front, okay? So you're just gonna run this one function here. And as you can see here, year column is now at the very front, and then there is the rest of the data set, okay? Then another thing that you might want to do is basically relocate a column and place it somewhere specific. So it should either be before or after another column. And in this case, for example, I want to have the sex being sorted after the column species. Okay, so what you do is basically use relocate again. You specify the name of the column that you want to relocate, and then you use dot after, okay, to specify the name of the column after which you want to put the column of interest, which is sex here. Okay, and then you run this, and you will see again that year is again at the end, and this is why we are not assigning any of these changes into an object. So basically, Penguin's data set is staying the same all the time. It's literally just the output that we're seeing in the console, just to show you how these functions work. Okay, and we see here that now we have species, again being the first column, but then we have sex and then island. And then what you can also do is, for example, to just sort the columns depending on their data type. So for example, I want to have all numeric columns at the very end. Okay, so what you can do is you use, again, relocate, And then you use another function here, which is where. And I think that I can even remove these parentheses here. Very sorry for that. Okay, so you use the function where, okay? And then you say it should be the numeric columns that you want to place somewhere else. And then you say that you want to put them after the last column, okay? So you use after here, and then you use last call here. Be aware that whenever you use where here, you do not have to use the actual isNumeric function, which would include using the parentheses or the brackets. So just remind yourself that here you can basically ignore the brackets, just put the name of the function inside, and R will know exactly what you want. So if we run this now, okay, perfect. We see now that we have species, island, sex, and the year here at the beginning. And to be honest, I'm not sure why year is here, because year is integer, which is almost the same as numeric. And both flipper length and body mass are also both integers. So I'm not really sure why this happens. But however, we do see the species, island, and sex, for which we know are factors. So they're not numeric. These are at the very beginning now of the data set, while all other columns are at the end of the data set. Okay, so for me, for example, this would be a much nicer way of having my data set sorted. And then the last of the basic functions here is arrange, and this can be used to reorder rows. So relocate is for columns, arrange is for rows. Here, it's important to note that if you have any NAs in your data set, that these are always going to be sorted at the end of your local data. So even when you are using the wrapper descending, okay? And just another note is that the default for this function arrange is always in ascending order, okay? So for example, here, I want to order my rows by flipper length, okay? But in a descending order. So from the largest flipper length to the smallest, okay? So you just, again, use penguins, the pipe operator, then arrange, and then we say it should be in a descending order, and then the variable of interest. And if we do that, we see here, if you go to flipper length, that now it's in a descending order. So this is why also in this case, for example, Gento is the first species that we see here because it has the largest flipper length over the entire data set, okay? And what you can also do, for example, if you want to order the data depending on multiple columns, you can also just insert name of these columns and just make sure that you know that if you insert flipper length first, that R will first sort everything after flipper length, and then will sort everything after the body mass, okay? So you can do that as well. And then we would get a slightly different output here because I'm not using the descending order anymore. So I'm using so it's just in an ascending order. This means that here we're starting now with the species with the smallest flipper length. Okay, good. Then, for example, what you can also do is to arrange these rows within each group. So what we've just done is that we arranged the rows for the entire data set. So here, obviously, the order of the species might change depending on which species is the largest or the smallest, or has, in this case, the largest or the smallest flipper length. But if you want to do it by group, you can also do that easily by using the function group by again. So here we just want to group our data by species and sex. And then we want to arrange the data by the body mass. And the important thing to say here is that you need to include the by group argument. So by group equals true, so that R knows, yes, you really do want to arrange those rows depending on the groups. If you do not include this, nothing will happen, even with having the group by here. I just tried it and it doesn't work. So you need to specify this argument here as well, okay? I'm going to be using view here. So it's a wrapper function around this entire R chunk here, which is basically just going to open the entire data set in a new window so that we see all columns and all rows, okay? So if we run this now, we will see here that now we have Adelie again being the first species here. And then we have Chinstrap at some point. Yeah, and then we have Chinstrap and then Gento at the very bottom. So now we have Adelie sorted by body mass and by the sex. So we first start with the smallest female, and then we have the smallest male here, and so on. And then this repeats for the 2 other species. You can also only show some of the rows. So we just saw the entire data set rearranged, but maybe you just want to rearrange the data set and then just slice the entire data set into just a few lines that you want to see. So for example, in this case, we only want to see the first 5 lines for each species and each sex, okay? So it's the same function as before. Everything is the same. We just added slice head here, okay? So if we run this now, we're going to get a slightly smaller data set, and this one now has only the first 5 females with the smallest body mass, and then the first 5 males. For Adelie, we also unfortunately have some NAs here again, so just ignore these, but you can still tell that it worked and that we here now have a small data set, so it basically has only the 5 smallest individuals for each of our groups, which are here the 2 sexes and the 3 species. So these were the basic functions of the dplyr. Then there are 2 other really, really great functions that are super helpful if you're doing, for example, some summary statistics and calculating these either across multiple groups or across multiple variables. So first thing that we're going to do here is to use summarize to just calculate the mean and the standard deviation of the bill length. Okay, so I'm just going to be looking at this one specific column here. So again, we're going to be using the dataset penguins. We're going to group it by species, island, sex, and year. Okay, so I want to have it in groups again. I do not want to have an overall mean for each species only, but also for each island, sex, and year here. And then we're going to use the function summarize. And here what you do is that you first give a name of the new column. So totally easy, just mean bill length, but it can be anything else. It can be banana, it can just be bill. It doesn't really matter as long as you know what you are doing here and what this column represents. And then you use mean, just the function mean as you would usually use it. And then the name of the variable of your interest. And then here, importantly, there are different ways of doing this, is that you add this argument here, which is just telling R it should first remove all NAs from the data set and then calculate the mean and report it then in your new data set here, okay? And then you do the same for the standard deviation. And if we now run this, we see here that everything else is gone from the data set, right? So we literally only have those 4 columns of interest. And then we have the 2 new variables that we just generated using the function summarize. Okay, so now we have the mean bill length and the standard deviation of the bill length for all 3 species by each island, sex, and the year. Okay, the reason why we have an NA here is basically that it comes from the sex here. And I think there was just one single value probably. There is no way to calculate the standard deviation. So just ignore this for the moment. Okay, if we now, for example, and this is a really useful thing to do, just change year to a factor, then we can write this whole thing a little bit differently. So we're just gonna reassign this as a factor. So it's just penguins, $year, and then assign to, and we're gonna use the function sFactor here, okay? I will just also show that the structure changed. The structure of penguins here now has a factor here for the column year, okay? So what I'm doing here now is that I'm using the function group by if, and then I'm telling R that I want to group this data by all columns that are not numeric, okay? So I'm using negate here to say not, and I'm using is numeric here. The reason why you can't use the exclamation mark here is just because it doesn't work within dplyr in this case. I can't really tell why and who came up with that idea to not make it work. So I just did a quick Google search and found that you can use either negate, or there is also another syntax that comes from the package per, but this sounded very logical to me, so I'm just going to keep it like that, okay? So basically what you're saying is that you want to have all the columns together that are not numeric, okay? I'm going to show something in a second as well. And here we're using the group by if, okay? And this is solely because we're giving it a condition here. And then you just repeat whatever we've done before, and then you just run this. And it basically gives you the very same output. So again, we have these 4 columns here that we are using to group our data. And then we have the 2 new columns that we generated, okay? Or what you can also do, and apparently this is a better way of doing it, so, or like a more modern way, let's say, is that you still keep using the group by function, but now you use the functions across and where to specify that you want to have either the numeric or factor or whatsoever data type in your columns that you want to group by, okay? So instead of using group by if, where you give this condition, we're going to be using group by and then across. So it's looking at all of your columns and then finding only the ones that are a factor, okay? You could also, I think, put the negate is numeric in here, but I'm not sure, to be honest. So let's just keep it like this. And if you run that now, again, we're going to get the very same output as we had before. Again, the 4 columns that we're interested in, and then the 2 new columns that we just generated using the function summarize. One difference that I think is probably the most prominent one between summarize and mutate is this here. So you can basically use them in the same way. So we're going to, again, just use the group by here. It doesn't really matter which of the 2 versions we are using. But instead of using the summarize function, I'm going to use mutate here. Everything else is the same, okay? The same chunk of code, basically just change the word summarize into mutate, okay? When we run that, the output looks different. What we have here now is basically an entire data set again, okay? So it's keeping everything together, and it's just adding those 2 new columns, okay? So we again have here the columns as we had them before, also in the very same order. So it's not changing the order of the columns, for example, in the way that we are specifying them in the group by factor. But it's giving us here the values that we actually need, okay? And this here might look kind of a little bit weird because it might look like it's just random values and you might not even be sure if this is exactly what you need, but you can basically change the order here, okay, just by clicking on this here. And it will now only show you first the females and then the males and so on. And you already see here that you're looking at, for example, the island Torgerson for the species Adelie. And if you're looking at female and then the year, you see that the bill length here, which we know is now the mean value, is the same for all the rows that refer to exactly these 4 variables from these 4 columns, okay? So Adelie, Torgerson, and then females from 2007. And then the standard deviation also. So we see here that this is basically all the same. And then it changes whenever you change to the other island here, for example. So this way we know it all worked out. So we did calculate the mean and the standard deviation for each group, but instead of having it summarized in a small data set where we only have the 2 new generated columns plus the ones that we were using for grouping, we are again having the entire data set, but we are just adding columns to this data set. And obviously, some of the cells are going to be repeating themselves. So some of the words are going to be the same because obviously they're the same across the groups that we just specified. Okay, I hope this was not too confusing. What you can also do is to use the function across if you want to apply a function to multiple columns. So often you would have different variables, but you want to know not only the mean of only one single one, as we did here for the bill length, but we want to have the mean for several columns. So you can either just use across and then add the names of the columns in here and just say bill length, bill, I think it was depth, and so on. Or, for example, in this case, I want to have the mean value for all columns that are numeric in this case. Okay, so I'm first grouping everything by a factor. Remember that year now is a factor. Okay, so it's the same as we did somewhere before. And then I'm using summarize again. And I'm using now across and saying that I want to have all the columns that are numeric, and I want to have the mean calculated, and I want R to remove all NAs before it's calculating the mean. And if we do that now, remember it's summarized, so it's not mutate. We get a data set that has the 4 columns of interest that we use for grouping. And also it has all of these numeric columns now, but they now do not have the row data. They now have the mean values. What you can see is that the name of the columns did not change. It's very important, therefore, that you, for example, do not assign this into an object of the same name as your row data. So maybe use something like stats penguins or summary penguins or means penguins. That would be probably the best, so that for you it's clear that these are the mean values and not the row values. Okay. And if you again, for example, just try changing the order of any of these columns. So for example, you want the column to be ordered by sex, or you can also have it ordered by the island or anything, or by the year. We see here that, for example, for Adelie, for the island Bisco, and for the females, we have those 3 years. So the year 2007, 8, and 9. And for each of them, we have one value for the bill length, one for bill depth, and so on and so on. So these are all the mean values for these groups that we created. Another example where to use mutate is to calculate something like the deviation of each measure from its group mean. This is something you would often want to do if you're looking at the distribution of your data. And if you want to know if your data is normally distributed, there is one of the rules that is saying that the proportion of the data that is within the mean plus minus 1 standard deviation has to be 2/3, which is approximately 67%. Okay. There are different ways how to do that. I'm just going to show something that is more or less useful. It might be a little bit complicated, and it took me a bit to get this all together, but I do hope that you're going to see some important elements from this that you might find useful. Okay. So what I'm doing here now is that whatever I'm doing, I'm assigning it into an object. Okay. So I'm calling this object stats penguins now. Okay. And I'm using several different functions all together to create exactly the output that I want to have. And I'm going to do it in several steps just to make sure that everything is correct. Okay. So first thing that I want to do is that I only want to look at the body mass. So I'm going to be keeping those 4 columns that are used to basically group our data. And then the only variable I want to look at is the body mass. So I'm first selecting only these 5 columns. Then I'm removing all NAs for the body mass. Okay. And then I'm again grouping everything by all columns that are a factor. Okay. And then I'm arranging all of them by basically those 4 first factors, just to have it nicely arranged. Something that you do not have to do, or you can. I just think that it's nice to have all of them ordered so that you can really see what is exactly happening rather than having them all mixed up. And again, I'm using here the by group equals true. And then I'm using the function mutate. So all the other functions above that are basically used to get the data in a format that I want to then use to do something with it. Okay. And now with mutate, first thing I'm doing is that I'm calculating the mean of the body mass. And I'm doing this for each species, each island, each sex, and each year. Okay. So these are my groups. Then I'm calculating the standard deviation, again for the same groups. And then I'm calculating the mass deviation, which here is basically just each single measure of body mass minus the mean of the body mass. And it doesn't matter which way around you do it. You can also do mean minus the individual measure, or this way, it doesn't matter. Also for later, it doesn't really matter. So it's basically just then giving me a difference between body mass and the mean. The important thing is that here, because I group the data, I will know that this mean that I'm using is going to refer to a specific group. So this means that if I have the individual body masses for the species Adelie, from the island Bisco, from females, and from the year 2007, what I'm going to be subtracting from this individual measures is going to be exactly the mean for that one single group. Okay. And the reason I'm doing it like that is that I'm basically using mutate to first group everything by the actual columns of interest, which will then calculate my mean. But then I'm using mutate to be able to calculate each individual difference. Okay. If we do this, we do not see any output here, but we can just call our object. And in our object, we see here now that we have the species here and then island, sex, and year. And we see that they are really nicely ordered. So first we have Adelie Bisco female, and then the year 2007, and then the year 2008. And then obviously here we have the body mass in grams. So these are the individual values. But then we have the body mass mean, and you see here that it's the same for the same group. So here for the year 2007, we have 3,470, and we have the standard deviation of 315, and then the actual deviation between the individual body mass and the mean is minus 70 here in the first line, which is just 3,400 minus the 3,470, and so on. Okay. For example, what you can then do is to use the function case when to specify a new column that will have the input yes or no, saying if this deviation is indeed within one standard deviation. So this is what we are trying to get now here. Okay. So what I'm going to do is, again, I'm going to use mutate, because this is going to keep my data set together, and this is going to do something to every single row of my data. Okay. I'm going to create a new column, which I'm going to call within. Okay. And then I'm going to use the function case when here. What you do here is that you basically just add your different conditions. And then for the case R finds that this condition is true, what is then the thing that you want to insert into the column at that specific row? So what I'm doing is that I'm taking the absolute value of this deviation. So this is why it does not matter if you're doing single value minus the mean or mean minus the single value. Okay, so using the absolute value of the deviation and checking if this is smaller or equal to the standard deviation. And if this is the case, then it should get the string yes. So you use the tilde here. So this is your condition. This entire part here is your condition. And this is whatever you want to have inserted into the column within for the case this condition is true. Okay, and then we have the opposite condition, basically, which is then saying that the absolute body mass deviation is larger than the body mass standard deviation. Then we want to have the string no in this case. Okay, so if we do that and then check the stats penguin here, we have another column here, and we see here that it says yes for the minus 70, because the absolute value of minus 70, which is 70, is within 315. But then for 330, we have a no, because it's above the 315, which is the standard deviation in our case. And then the last thing that you would want to do is now to finally calculate the proportion. Okay, so we first calculate the sample size, and I'm just going to insert this here. And then the proportion of data within mean plus minus one standard deviation. Okay. So what we're doing here is, and this is a little bit tricky, I'm really sorry for this. Probably there are easier ways to do so. I'm first again grouping the data by species, island, sex, and year. So the 4 columns that we have been using so far anyways. And then I'm using mutate to calculate the sample size. So I'm just going to call it n sample. And to do this, I just use length and then the body mass. Okay. And then in the next part, I again use group by. So I'm grouping again, but this time I'm also grouping it by within, because now what I want is that I calculate basically the numbers of cases that are either yes or no, and then divide this by the sample size, and then multiply the entire ratio by 100 to basically get the proportion in percent of the values that are either within or outside of mean plus minus one standard deviation. Okay, so I'm just using this here to basically subdivide these data into 2 parts. The reason I can't do this before is because I need to tell R first to get the entire sample size. which includes both yes and no for the column within. And then I just have to repeat that again. I'm not sure if I really have to group everything again because the data is already grouped. So it might even work with just leaving this out and then here just grouping by within. You can try that yourself. But this definitely works. So what we get, and I didn't put it here, I will add it right now. Stats penguins is this here, okay? So here again, we have all the rows that we had before. It's just that the body mass is now removed and the mean and everything is now removed because we were not grouping by that. So whenever you summarize, all of the columns that you're not using for grouping are basically lost, okay? But we still have the number of rows as we had before. So for each of these single values, this is kind of a little bit unhelpful here because obviously we just want to have one single row for each group that has a proportion of the values either within or outside of this mean plus minus 1 standard deviation interval. So what we can do, and as I said, not probably the perfect way of doing this, to just filter out first only the rows that have yes in the column within, because that's what we're interested in, and then just find the unique ones. So this will basically kick out all the duplicates that we have. So for example, from these 3 first rows, it will just going to keep one of them, okay? And what we then get is a really nice table or data frame in this case that has those 4 columns that are basically grouping our data together. And then we know it's only showing us everything that is within mean plus minus 1 standard deviation. And this is now giving us the proportion. Okay, cool. Then we can move on to gather and spread. Gather and spread are 2 functions from tidyr, and they can be used to switch between a long and a wide format of the data. They both work with 2 arguments, which are key and value. If you're using gather, then key stands for the name of the new naming column, and value stands for the name of the new result column. Okay, so what we're going to do here is that we're going to take the dataset penguins and we're going to gather it, so make it longer. Okay, so we're going to go from wide into long. And what I'm going to do is that I'm going to take all those numeric variables, basically, so all the measures that we have, all the traits that were measured, and I'm going to put them into one single column and then have another column that has all the values. Okay, so I'm going to call this traits measure. Could have also called it trait, just figure it out. And then going to call the basically the result column value. And important here is that you tell R that you do not want some of the other columns to be included into this gathering process. So we still want to keep the column species, island, sex, and year as they are, but we only want to gather all these other columns. Okay, and if we do that, we end up with this here. Okay, so this is also keeping the NAs, by the way, just so you know. But here we now see that we have the bill length first, okay, for all the values. So there is nothing lost, basically. It's just the bill length first. And then at the end of bill length, sorry, this is really long, we have the bill depth. So all these values that were in the different columns are basically now just put below each other. And then the rest of these columns is just replicated again. Okay, so now we have a long format compared to the wide format that we had before. Okay. Next thing that you can do, for example, which I think in this case is really useful, is that you now calculate the mean, the standard deviation, and in this case also the sample size for each group of interest, the same way as we had it before, but also for each of these different traits or measures. Okay, so this is a little bit easier than we had it before, where we basically either calculated all of them, but then we had another data set that had the same column names as we had it in the original data set, which can be confusing, or we were just calculating the mean of only one single variable. So here we have all of these variables in one column, basically, and then we can just create new columns that we're going to call mean, SD, and N that are going to represent the mean, standard deviation and the sample size of the values that we are interested in. And here first, we're gonna again use gather because I haven't assigned this into an object. So again, we use gather the same way as before. Then we first filter out all cells for sex and value that are not available, so or NA values. And then we are grouping everything across all columns that are not numeric. And then we are summarizing everything by mean, standard deviation, and the sample size. Okay. And what we're getting here is a really, again, pretty huge data set. But we see here, we start with species. So Adelie from Biscoe Island, females from 2007. And then we have a mean value, the standard deviation, and the sample size for each of these traits here. Okay. These are mostly going to be the same, except if we, for example, had an NA value for one of the traits. But apart from that, you should get the same value here. But obviously, the mean and the SD are going to be depending on the actual variable that you were looking at. Okay. So this is also pretty useful. And you now have an entire huge table with all the groups of interest and also with all traits of interest with means, the standard deviation, and the sample size. If you want, you can also assign this to an object. So I'm basically copy pasting this entire part except for the wrapper function view here. And I'm just assigning this to an object that I'm going to call summary penguins. Okay, so I'm assigning it here. And then if we look here, for example, also, we see that's exactly what I just shown. And what you can then use, and this is the last part for today, is that you again now spread the data if you want to. So here, we're going to again use the arguments key and value. In this case, key is the column that you want to split apart. Okay, so it's again going to be the measure. And value is the column that you want to use to populate the new columns. Okay, so we have the measure, which is basically the traits. Okay, so build length, build depth, and so on. And we have a single value that we want to basically use to populate these. And in this case, I'm just going to create another data set, which is here going to be the means penguins, similar as we had it sometime before. And now I'm going to select only the relevant columns. So all the 4 grouping columns, then the measure, and then only the variable mean. And I'm going to use the key measure and the value mean to basically spread these columns. And if you do that, and if you then look into means penguins, then you see here that now we have for each of these traits, the mean value in these columns here. And it's again for each species, each island, each sex, and each year. And there are no NAs because we have already excluded them somewhere before. Okay, so this is it for today. I think this was already quite a lot, but it's summarizing those basic functions that you can use from dplyr and from tidyr. And I do hope that I will be showing everything else in the next video. So I will try to combine ggplot with dplyr, show you how to use that, and also show you how to use the broom package and probably also the per package for many other really cool things. And if you come up with anything else that you might be interested in, or if there are any questions to this, because I have not explained everything in the most detail, then you're always welcome to just let me know, put a comment below the video, or just email me and let me know if there is anything else that you will be interested in. Okay, I hope you enjoyed this and see you at the next video. Bye-bye.